So this was the quiz. I wanted to go over the solution to make sure everything was clear. The rate constant for a second order reaction is 0.13 molarity to the -1, seconds to the -1. And then you're given the initial rate and how long does it take to get to 0.13 moles per liter, which is in fact half of that. This is the integrated rate law on here right now. For a second order reaction, you just need to know the integrated rate law for what matches up with what for first order and for second order. You are given, I will give you all the equations, integrated rate laws for 0, first, and second order, but you have to know which one's which. Because it's a second order reaction, you can write this rate law. Now we're substitute in numbers is 0.13 is what it ends at after some amount of time. You put the K value in with associated units. We do not know the time, 1 over the initial concentration, which is 0.26. Those concentrations are given in moles per liter, which is, of course, the same as molarity. To solve this, I just put 1 over 0.13. Actually, technically, I did it as 0.13 and then hit the x to the -1 button, minus 0.26 and hit the x to the -1 button, and subtracted those. And so that gives me a number equals K, the 0.13, molarity to the -1, second to the -1, times time. Solving for time, molarity to the -1 will cancel out, and you will, in fact, be left with seconds. So it would take about 30 seconds. I guess to round that with significant figures, you would have to put 30 seconds. There is another option. This is not on the AP equation sheet, but I will give it to you just in case you needed it. And that is to use the half-life equation. This one, of course, you can only use just because this is half of the concentration. You're starting with 0.26 and going to 0.13. So then for number 2, for a straight line for 0 order, that's when you just have concentration versus time. For a first order, you have natural log versus time. And for second order, it's 1 over concentration versus time. If you know those, you would know which integrated rate law goes with what.